Hello everyone, welcome back to my YouTube channel. So in today's video, we're gonna go to the next problem. We're gonna have implementation and extra solutions. For the previous one, we were talking about the quickshot algorithm. So in today's videos, we can move to um, the other topic, which is binary search. And I could create a new file. Search. I'm going to use C++ plus this one. Let's close this one. So for the problem we have, so let's read through it real quick. The post has a meeting room and so there's n people who want to book the room, and the number of persons start from I to n, and it has start time and end time with pi, which corresponding to the each person. So the pi is the start time and end time of the I person. So we have the two meetings. This is the condition, and if the two meetings I and Y and J can occur simultaneously, this will have the pi less than or equal to aj, and the bj is less than or equal to ai, which means that it will not overlap and disrupt each other from the start time to another start time, also with the end time. So the task is to determine the maximum number of people who can rent the room. So for the input, I'm gonna read from the terminal. The n is the positive integer. For the n booking from persons, and the next n lines will include the ai and bi, which is the start time and end time of each meeting. The output will print out the integer representing the maximum number of people that rent the room. So for the test case, we just notice that we have n people and we have n pair of start time and end time. So this problem comes into the longest increasing subsequence. So for that we can use different approach, but in this tutorial we also use the binary search. We can easily pass all the test case, because the n is just less than or equal to 5,000. So for the binary search, we just with the performance of n log n power by 2 multiplied by log n, logarithmic of n. So now we're gonna go to the implementation. First of all, we import the library, which is std c++.h. This includes all the building function and type variable types like vector to stack. So that we use this library and use the namespace of std. So as we already know, std namespace is used to shorten the code of this std elements from the namespace. So we don't need to use the std double columns like this every time during the code. So we will move to we can define pair with the elements of int, like the pair of two-dimensional to integer, like this mv pair int colon int. So this can help us to shorten the cost. And can redefine the average for the average. The f array is just used for the prefix, not prefix sum, but to store the previous room that we already checked. So it's kind of the dynamic programming, but just apply the sum point. So have the width of 5,000. We also the length of n in the problem statement. So we want to divide the rest variable with the result and x point. For now, I just divide these variables, and for the following course, I will explain what these things are working to make working. At the vector of mp. So this is the vector of two-dimensional element. So you can call it as v for the short of vector. Now let's create the main function. I used to utilize this light to improve the performance of the code by the code running time. So we're gonna use this light OS-based scene. So this line will help us to diminish the written input time. It's a benefit of competitive. Even like some competition about algorithm, most of the participants they use this line to do some trick about performance, like if you decrease the total performance by one millisecond or up to 5 milliseconds. It's kind of beneficial. So from the terminal x and y, is A, AI and the PI in the problem statement. So you push them into the vector with the empty defined pair. So it's a pair of x and y. To use the binary search, we need to sort out the vector first. This comparing function is used to give the condition of the sorting function. We want to define later on. Gonna give the rest value of 0 as a initial. Then make a for loop from initial I starting from 0 to n. In this for loop, we're gonna integrate the research function. So after sorting for the nearest pair for the current vi, like that is not disrupted with the vi the second is the end time. So we're gonna find the nearest pair of in disrupting from the current pair. Define this one we're gonna use some prefix sum for this is kind of the prefix sum algorithm. It's just to us the sort of integration. Highest is equal to 0. So we're gonna redefine the pre-I, the fi. So it's just a initialization of our prefix sum. So also we're gonna prefix the previous pre with the newly created fi. So this one is we're gonna because we're gonna find the maximum number of the bookings for the room in the problem statement. This one we're gonna compare the previous so this one we're gonna compare the previous number that we found series the highest one to the current one. So for the result variable to show the maximum of the result and the current fi. The previous of the pre-array, we're going to use it inside the binary search function. So we just put it here. It's kind of weird at the moment, so we're gonna define the function real quick. gonna make a bin function, which is a short form and research in run, which are valuable in the var here is just the current vi dot first with the start time of the current booking. So modify the L and R. The L is 0 and R is n minus 1. We use the zero based indexing, so okay, go to 0. So okay, just a checking variable. Y. So the condition to break the while loop is L greater than R, which most of the condition for memory search. So modify the bit is the which means the middle. So is equal to L plus R divided by 2. So we're gonna find the middle of the array. Use the limit is the center of the vector v of the mid second n time. We check that it was less than or equal to 1, and we're gonna assign the value of v mid to k variable. I'm gonna increase the L by mid plus 1, so that we're gonna find the right side of the current searching. I was gonna just assign the value for R by the mid minus by 1. So with respect to the binary search, so after this process, we apply the k with the from the pre-mid. So at the position of the mid, it will be compared to the value that we assign to this function as initial. So this will verify the nearest less than the nearest less the nearest pair that has the less n time compared to the start time of the pair that we want to make conversion. So yeah. So we're gonna have a question why you say the variable k with the limit. What's the pre? It's just the prefix, uh, just using the prefix of freedom. So um, for the pre-array, the application will use to find the maximum number of booking room at the current position of I. So that we gonna assign this value to the k, and the return k will be assigned to the results variable. So for now we already get an idea. So this is the last function for the implementation. So for the concurrent function for the 14 below in the main function. So in here we already define the short function for the vector v, where we're gonna repeat some condition like this function psi to value a and b is of type np. Let's set so the end time is of a is less than the end time of b. So then we can return true. That's a single with single condition. We know that the booking is is, is greater than the booking A in terms of booking time. So this one after that we use the else. Usually we can use LB right here. LB. Let's second. Later then wait a second. So it's opposite to the first condition. Return the first. And for the else outside this, we return for the case of the two is equal. So we're gonna return the date of the first. It's less than the first. So this way we can sort out we can rearrange the vector v in ascending order. So this, and then everything is going well. So just run this point to see if we already origin. So for the input we will use the test case. First, we have some error. Now we have double R here, which is not correct. Arrow R was not declared in this code at the port is at the 25th line. 25th. R is not declared. Was not declared. Yes. complex typing is this one is the lower hyphen, not the middle hyphen. Let's see if we have any else. Static semicolon before practice. Oh, so this is a common mistake that usually making a plus sign. This one should be the semicolon, not the colon. We're missing one semicolon in the line of 16, 60. Okay. Check if this fine you can open the arrows. Okay, sorry, corrected. Okay, so I'm gonna use the test case. So we have for booking first one from 8 to 10, second 10 to 20, 2 to 13, 14. Well, the output is 3. So yeah, assuming the output right here. So I think we're gonna use some custom test case. So we check to ensure that the output grows. And for booking, one from 1 to 10, second from 1 to 9 is corrected with the first one. So this one. So the first one needs to be excluded for the results. So this third one is from 10 to 15. The fourth is from 16 to 17. So we can the outputs will be 3. Yeah. I think it's so good. So I think that's it for today's videos. I will post some more videos on day-to-day basis, so just stay tuned for the more complex problem, which I will keep posting on this YouTube channel. I think the next episode is about the binary index tree, which is also called the Fenwick tree. That's really valuable stuff for algorithm understanding, and actually that kind of Fenwick tree is really valuable in many cases. So see you in the next tutorial videos. I'm gonna end this videos just now. So hope you're doing good. So let's see you in the next episode.